Good morning, everyone. So, myself, Dr. Anju. I am from AKGEC Garg Engineering College. And yes, in the previous lecture, we have discussed on the binomial heap. So, how to create a binomial heap and how to perform the merge operation that we already have seen in the previous lecture. Today, what we are going to discuss is the different operations that we can perform on the binomial heap data structure. So, as a precursor, I just want to go through once again about the binomial heap. So basically, a binomial heap is a collection of binomial trees, and each binomial tree satisfies the minimum heap property here. So we can think of a binomial heap data structure as a collection of multiple minimum heaps that are connected together. And each of these binomial tree of degree k has 2 raised to the power k different nodes present in it. So I can also say that, for example, if I need to, for example, say that we need to create a binomial heap of degree, for example, 0. So this B0 binomial tree we are going to create by total number of nodes we can compute from the expression 2 raised to the power k, and k here is equal to 0. So we can say that this binomial tree is going to have only one single node in it, and we can represent it like this. So we are only having a single node here in case of a binomial tree with degree 0. Similar ways, for example, I need to create a binomial tree with degree 1, then it is going to have 2 raised to the power 1, that is equal to, for example, 2 nodes, right? So here, how we are going to create these 2 nodes together? So we are taking 2 binomial heaps of degree 0 like this. So this is one B naught and this is another binomial heap, and then we are connecting this as a left child of the previous binomial heap. So for example, if this is a binomial tree, I am connecting another binomial tree, and both of these binomial trees were of degree 0. Now the combined structure here, this becomes of degree 1. So that way recursively we can create more complex binomial trees. Now we are going to see that what and how many operations we can perform on the binomial heap data structure. So we can do the creation operation over the binomial heap, how to create a new binomial heap. Then we can go for merging or union of 2 binomial heaps that we already have discussed in the previous class. Now finding out the minimum key from the binomial heap, this is also called as the search operation here, that we need to find out about the minimum key, and inserting a new node, decreasing the value of a key, for example, deleting a node, and then extracting the minimum key. So these are the possible operations that we can perform on the binomial heap data structure. Now today we are only going to discuss 2 of these operations. One is called as the insertion operation. So how we are going to insert a new node into the binomial heap data structure, this we will discuss in a moment. And the second operation is the extraction of the minimum value. So how we are going to find out that which value is minimum, and then we need to extract it or delete it from the binomial heap. Now the first operation is the insertion of a new node, and how we are going to proceed for the insertion operation. So there are certain steps that we need to follow. First of all, we need to create a new heap with the element to be inserted. So for example, if I want to insert a new node, or for example I want to insert a new element into an existing binomial heap, the first steps that I need to create a separate heap with the element value that I need to insert into the existing heap, and then I need to perform the merge operation with this with the original heap for this newly created heap data structure. So once, for example, I have already combined or merged both of the heaps together, now the binomial heap property can get violated in this case. So how we are going to adjust the overall structure so that it conforms with the attributes of the binomial heap. So for that, again, we are considering these 4 cases, and according to these 4 cases, we are one by one applying them, and we are adjusting the resulting structure into the final binomial heap. So let's take one example, that how to perform the insertion operation on the binomial heap. So for example, we have been given a binomial heap like this, and for example, this is the new node that we want to insert into this particular existing heap. Now, for example, as I already have said that we need to first create a separate heap representing this new element. So we have created a new heap data structure as hnew, consisting of only one single node containing the element value that we want to insert into this heap, right? And as you can see that once you have created this heap, this only contains one single binomial tree, and this binomial tree is going to have the degree 0. So we are going to have one component here which is having a binomial tree with degree 0. Now, in the original heap data structure, we are having different binomial trees connected together, and the degrees of these trees are, this is for example B0, this is with a degree B1, and this is with a degree B2, right? Now, the first step now to insert this node into this existing structure, first I need to combine these two together, right? So how we are going to combine or merge them together? For that, I need to pick up this value, and then I am inserting it into this structure. And how we are going to perform this the insert operation here, that we are starting with the heap pointer, and then we are searching and looking for the appropriate place. We need to remember that since the degree of this heap or this tree actually is 0, so we are starting from here and inserting it at its correct place. So I have found out that this is the correct place to insert this particular element here. So next what I will do, that I will insert 15 after 10, and now we are having all the binomial trees in this data structure in a strictly ascending order, right? So this is the first thing that we need to remember. Now let's combine both of the heaps together. So we are having, for example, the heap pointer points like this. This is H. We are first creating a node 10. This is P0, and then we are inserting the new element or the new tree, binomial tree with degree 0 here, right? And the rest of the tree we are going to copy like that. So 8 and 20, this is the next component we are having. So 8 and this is 20, and then this points to the 17, 28 and 40. So we are writing 17, 28, 40 and 52. So now we need to write the degrees here. So this is a binomial tree with degree 1, and this is a binomial tree with degree 2. So as you can see that the combined operation or the merge operation is performed here, and now we are having all the binomial trees in a strictly ascending order. Now what I need to do, that I need to check whether it is conforming with the binomial tree properties or not, binomial heap properties or not. So as you can see that in a binomial heap there could only be one single tree with a given degree. So here we can see that there are two such binomial trees which are having same degree, and this violates the condition of the binomial heap. So we need to readjust this binomial heap structure so that it conforms with all the properties of the binomial heap data structure. How we are going to do that? So we already have seen that while we merge two heaps together, or we are taking the union operation of two separate heaps together, then in that case we have to check for the 4 cases, right? So if you remember, the first case says that if the degree of x is not equal to the degree of next of x, then in that case we need to move the pointer. The second case says that if the degree of X node is equal to the degree of the next node in the heap, and which is also equal to the degree of the sibling of this next node, then in that case again we are moving the pointer ahead. Case 3 and case 4, they are actually checking two separate conditions here. The first condition is about checking the degrees of the node X, the next X, and the sibling of the next X. And the second condition is that we need to also check for the key value present on node X and next X. And whatever the case is applied according case 3 or case 4, we are taking appropriate action. So as you can see in case 3, if this case is satisfied, or if these two conditions are satisfied, where the key present at X node is lesser than the key present at the node next to X, then in that case we are keeping the key or the binomial tree with key lesser than the other one, and we are simply removing this key or this next X binomial tree from the binomial heap, and we are attaching it as a left child to the original node X. Okay, so this way we are actually performing the merge operation. And in case 4 we are simply doing the reverse, right? So in this case we are keeping the next X and we are removing the binomial tree which is rooted as node X, and we are attaching it as the left child of next binomial tree, which is represented as next X here. Okay, how this is going to be do? So for example, first of all we need to mark the pointers here. So for example, I take it as node X. So this I'm writing here, this is X, and this is called as the next of X, right? So this is my next X, and this becomes the sibling of next X, right? So we are having three different pointers set to the first three binomial trees present in our structure, right? Now one by one I need to apply the case, and according to that I need to take the action. So in the first case says that we need to check for X and the degree of next X. So if these two are not equal, then we need to move the pointer. So since the degree of X is 0, degree of next X is 0, the first case is not applying here, right? The second case says that if the degree of X and degree of next X and the degree of sibling of the next X, they are equal, in that case again we need to move the pointer. So in this case, degree of X, so I can write it like, for example, degree of X is equal to the degree of next X here, right? But it is not equal to the degree of sibling of next X, sibling of next of X, right? In this case, dx is 0, which is equal to d of next X. So d of next X is again 0, but it is not equal to the sibling of next X. So degree of sibling of next X is actually 1, right? So again, the second case do not apply here. So we move on to the third case. Third case says if the degree of these two are equal and the degree of the next or the sibling of this next node is not equal. So as we can see, 0 degree and 1 degree. So these two are equal, but this is not equal, right? So case 3 and case 4, both of these cases are applied here. As you can see, degree of first two equal, but the third one is not equal, right? So both of these conditions are satisfied with the current structure. Now we need to compare on the second condition, which says that if the key of X is greater or it is lesser than the degree of the next. So in this case, as you can see, that the key of X is 10, the key of next X is 15. Which one is lesser? This is lesser. So we are actually keeping the lesser one into the binomial heap, and we are picking up the next component or this component we are picking up from here, and we are removing it here and attaching this binomial tree as the left child of the first binomial tree. Okay, so now as you can see that once I do this, for example, this we remove, and now I am simply having a structure like this, right? Again, the degrees needs to be adjusted now. So as you can see, now we are having this component with degree 1. So now this is a component with degree of 1. So now in your structure, you have seen that we are having two components with degree 1. So again, the binomial heap property is not satisfied here. So again, we need to perform an adjustment by applying one of the 4 cases here, and again adjusting the whole structure. So in this case, again we are taking this as the x, this becomes now the next x. So for example, okay, so this becomes the next x, and sibling of next x is this one. Now the degree of this is equal to degree of this and is not equal to degree of this. So case 3 or 4 is going to be applied here again, right? Now which one is applying, 3 or 4, that we will discuss. As for example, this degree and this degree is equal, but this is not equal. Now we need to perform the comparison of the keys. So key of this is greater and key of this is lesser. So we will keep the binomial tree with lesser degree and we will remove this from here, okay, and we will remove this component from here and we will attach it as the left child of this. So now this will be attached here like this. Okay, so this component is removed. Now again the degree is going to be revised. So you are now having two structures, one binomial tree with degree 2, other one also with degree 2. So again we need to check for recursively this whole condition of the heap. Again, as you can see that degree of both of these binomial trees is equal, so we cannot keep it like this. Again we need to perform some adjustments. So now again we have to check for the cases. This is the x, this is the next x, now next of x, and sibling is not present. So sibling here is equal to null, right? Now you perform the whether the degree of these are equal. So degree of this and degree of this is equal, right? And sibling is null here. So of course we we are having the case again the 3 or the 4th, and again we need to compare for the key values present here. So as you can see, the key here is 8, here it is 17. So we need to remove all this component from here and we are attaching it as the left child of this particular tree. So you are having a structure like 17, then 20, then here 40, and there 52. Since this component has been removed from here, this whole component is now having a degree 3. So now you are actually having a binomial tree which is having a degree like this. So this is 8, we are having 17, then we are having 10, then we are having like for example 20 here, right? And this is going to have a degree B3, and right, so this way the final structure is with us. And as you can see that now only one binomial tree is having present here and with the degree of 3. So this is confirming with the concept of the binomial heap. So the final insertion has been completed this way. Now when we talk about the extraction of the minimum key from the binomial heap, we already know that the binomial heap is a collection of binomial trees, right? And every binomial tree present in the binomial heap is itself a minimum heap. So whatever value we can see on the root node of the binomial tree, which that will be the minimum from all the values that are present into that particular binomial tree, right? So to find out the minimum key, first what we need to do, that we need to compare the keys of the root nodes only, right? So I do not need to search into the entire structure, rather I just need to compare the root node of all the binomial trees that are making this binomial heap. And once I have located that binomial tree which is consisting of the minimum key, then I need to simply remove it, and again then we need to perform the readjustments. So how the readjustments are going to be performed, that we already have discussed by performing one of the four cases. Maybe the cases need to be applied recursively, and finally we will get the binomial heap, right? So again, for example, this is the structure and I need to extract the minimum key. I'm starting from this node, okay, comparing it whether this is having the minimum value. So this is having 10. Next you compare it with this node. Now which one is minimum? So this is minimum. So we are updating the minimum value to this, updating the pointer, and then we are again comparing 8 with 17. So now when you compare 17, you can find out that the minimum value still is 8, right? So this is the actual binomial tree which is having the value which is minimum, right? Now I need to remove this node from here, and then I will upgrading this node here, okay? So now what I have a structure like this. This is 10, I have 20 here, and then I will have 17 here with all the values intact, right? This is 52. Now as you can see that the minimum key of 8 we already have removed or extracted. So min has been extracted from this. Now we need to check the remaining structure is actually a binomial heap or not. So as you can see, there are two different binomial trees which are having similar degree, right? So again we need to perform the union or the merge operation cases over here recursively maybe, and that way the tree is going to be adjusted this way, okay? So this is all for today. Thank you very much.